Hey everyone, I welcome you all to today's Meshery Development meeting. Today is 26th June 2024, and if you are new to today's meeting, let me share you what we do in this meeting. So Meshery is and what is Meshery? So Meshery is a project which helps you to manage your cloud native infrastructure collaboratively in different Kubernetes in different environments with multi-cluster environment. And if you want to learn more about Meshery, you can check out the docs.meshery.io. In this meeting, we basically discuss the project features of various works that we have from the community members, maintainers, and community managers. So before going and starting to the agenda items, we do have a couple of housekeeping items. One is to make sure that you add your names in the attendees list. And the second is if you are new to today's meeting, we encourage everyone to introduce themselves. It can be anything like where you are calling from, what's your favorite club, maybe your name and what you do. So for me, I'm Yash and I'm hosting today's call and I'm contributing the Mishi for around a year and a half now. Yeah, that's my small introduction. So Charlie, would you like to go next and give a small
Hey,
introduction?
yeah, certainly, yeah. Hey everybody, I'm Charlie. I work on the developer relations team at Styra and on the Open Policy Agent project. I gather that you've been chatting to Anders about um, talking over that today. So, but he's not feeling that well, so that's why you've got me here instead.
Thank you, Charlie. Lee, I think you are muted if you're saying something.
No, I was just gonna, harass Charlie since it's his first time here. We need to indoctrinate him with sarcasm and I mean it's wonderful to have Anders backup on the call. So that's
Yeah,
Anders.
so no problem.
Yeah. I mean plus I mean not that you can tell anymore, but hey man, red hair, solidarity, a little bit. It's
Yeah.
just give it a few
Shared the
years.
shared experience there, being
Yeah.
teased about ginger in the class or whatever. Yeah.
Yeah. Oh, nice.
Thank you, Charlie. So we have Jen. Jen, would you like to introduce yourself?
Yes,
Yeah.
my name is Jayant. I belong to Ludhiana, Punjab, and I am currently pursuing my BTech uh, in chemical engineering from NIT Jalandhar.
Thank you, Jen. And thank you for sharing where you're calling from. Uh,
Thank
the next is Priyanshu, maybe, or Amarachi, if you
Oh,
want to
hi,
introduce yourself.
okay. Hi, I'm Priyanshu and I'm a third year undergraduate at NIT Hamirpur and I'm from Delhi, India.
Thank you. Actually, I think I got a net issue. That's why I wasn't able to got your name, but thank you for sharing. If anyone wasn't able to introduce themselves, you can
Yeah.
always share your stuff. Yep.
Hello.
Yeah, Amarachi, please go next.
Oh, okay. Good morning, good afternoon, good evening, everyone. I don't know what time it is. My name is Amarachi Crystal Omerife. I am from Nigeria, Abuja, and I am a DevOps engineer by profession. Thank you.
Thank you, Amarachi. There is lots of things that you wanna go through and wanna share the information or wanna learn from. So, yeah. If let's dive into the topics. If anyone are not able to introduce themselves, you can always introduce yourself in the chat, and we will make sure to welcome you. Okay, so let's jump to the first topic, which is on deep dive on the mystery relationship and OPAR. So maybe Jose or Lee would like to highlight on this. Abid.
Yeah. Well, I'll kick it off. I need more coffee. Today we're gonna take, I think, about half the meeting and talk about we'll talk about something that's really important to Meshery as a project. And it's hopefully the thing that a lot of users will find delightful as they go to use Meshery. So there are a couple of core concepts to highlight, to quickly touch upon, and then talk about how OPA and Rego are currently used in the project. Some of the some of the open questions that we have. For my part, it's open questions out of ignorance, if for nothing else, and try to understand whether or not we're headed in the right direction, or if there are things that we're just sort of blatantly missing. And so, yeah, let me start by describing models. Meshery has this well, let's share a couple of slides. Let's look at some stuff while we or Yash, if you're on the models page out there, that might work as well.
It would be nice if you can share the screen.
Oh, okay. Yeah, sure. You just backseat drive your mouse all day long. I was just on a Docker captain's call, and so lots of stuff going on with Docker. Yes. So when Meshery first started, had a real service mesh orientation. It recognized that there were a number of service meshes out there, and there still are almost 5 years later now. The architecture of the project and part of the scope of its original goal had been to recognize that infrastructure is diverse. Like anybody that runs infrastructure runs it diversely, mostly. Like usually you don't have all of the same thing in your infrastructure. I always use a terrible example, like here's the microphone I'm using. Maybe one of you is using the same one. Probably there are 50 other types that we're all using. So sort of a bad example, but to the extent that it's configurable, which it is, and droppable, which it also is. Only so many times though. It's okay. It's okay, baby. I still love you. Meshery is here to help people wrangle all that diversity and do it in a collaborative way. In order to do that, fundamentally, Meshery needs to characterize and model the infrastructure. And it's not just infrastructure, the way that modeling works. So another way of describing this Meshery models, there's two other ways. One is each of these integrations that we see here, we're saying, oh, Meshery integrates with, well, Argo 3 times. Argo CD, Argo workflows, Argo CD operator. It integrates with each of these projects. Underneath each of these integrations is a model. Each of these rounded squares represents a model. If we were to click into any one of these, inside of this particular model randomly, there are, if I could count, nine components, 9 specific, in this case, infrastructure components that Meshery itemizes and further characterizes. So if this were clickable, we can go look at one of these, but when you open it up, each of these pretty directly represents a Kubernetes custom resource. So for each custom resource, depending upon how granularly the teams that have created those resources have described these components, is what Meshery these resources. Meshery refers to each of these resources as a component. This model API gateway has 9 components. Each component has many different properties to configure. As it turns out, we're looking at an API gateway. This is a networking-centric piece of infrastructure. You could imagine that you might have a virtual VPC, virtual private cloud, and a link, a network-centric link, maybe from your API gateway to a VPC, or maybe in between VPCs. I don't know. There's no way I can keep up with all this. But in order for Meshery to comprehend the way in which this VPC link as a resource or as a Meshery component relates to any of the other components. So perhaps, I have no idea. Anyway, maybe a VPC link has a route, or you route to your VPC link, or I don't know. But these things probably at some point touch one another and maybe configure one another. And if you just sort of mentally think through that, in your mind, you might, somewhere in there, you've probably drawn a line to represent a network connection from traffic, HTTP traffic, or other types of traffic going into your API gateway, and maybe coming out of your API gateway. Oh, great. Well, that's a relationship. The fact that you would have traffic flowing in, or traffic allowed to enter into your virtual private cloud, Meshery, in the same way in which Meshery characterizes this infrastructure by breaking them down into individual components and having many different properties on each of these components, Meshery also characterizes and codifies their relationships, how these things do or don't relate to one another. When you start to think of those relationships visually, I was just saying, well, probably there's like a line between some of these. There's any number of ways to visually represent these relationships. We're going to talk a lot about relationships, because where OpenPA and Rego, they come into play in Meshery in a few different ways, but currently most significantly around in context of a relationship. Like let me show a couple just to familiarize us with, like, hey, if we're looking at two components, you wouldn't know it because they're not labeled, but this is a config map in Kubernetes, a standard resource, not a custom resource, doesn't matter, but it's a Meshery component. And maybe that, I don't know if this is a good example, but here's a service account in Kubernetes, and maybe this is a namespace. The example, the particulars of the example doesn't really matter, but the fact that these two components are adjacent to one another, and in fact are actually siblings, if you consider that they are both inside of the same namespace, whether they like it or not, they have a relationship. Maybe they're distant cousins, maybe they're super close siblings. That can be characterized by the relationship. And each relationship has a number of ways to specify that relationship. At a high level, they have the same parent. Maybe they don't know each other. Maybe they're boyfriend, girlfriend. Maybe they're, I don't know, maybe they're super close. Maybe they're quite distant from one another. The relationship that is codified into the Kubernetes model, like for these two components, these are two standard Kubernetes standard resources. So they're in the Kubernetes model. If we happen to be looking at the AWS API gateway, then it would be the AWS API gateway model. Now, great. So they have a relationship because they have the same parent. Right? We can further characterize that relationship with how intimate it is, or how they affect one another. And maybe they don't at all. They have the same last name, so to speak, or they don't. There's a number of different ways to visually represent these relationships. So maybe one mutates the next or augments the next. The fact that one is present, or the fact that one wants to bind to the other. Again, there isn't a label here, but what's happening here? This is a role, or a cluster role. That cluster role is bound to a service account through a cluster role binding. And how would you know that? Or how would you know that? Because it's visually represented to you. Hopefully it is at some point when these are labeled and you're working inside of your infrastructure, hopefully it becomes somewhat second nature, somewhat intuitive, and you can grok that pretty quickly and understand what's going on and how many times this particular role is used and what all service accounts benefit from it. But the way that Meshery understands it is because there's just a JSON document, a YAML document that not very long. It's just a relationship. It's a relationship definition. It just describes the fact that, if you want to relate, describes the fact that these two or these three can all participate in a relationship. And hopefully one doesn't get jealous of the next as they go to bind. Anyway, there's, so you describe that in the relationship. And now, great. So Meshery has a couple of hundred of these integrations, these models. Each of the models has X number of components. On average, it's about 8, I think. Just the average. Some have 50, some have 1. Meshery as a project, some of you are actively working on describing what these relationships are. Like, as a project, Meshery has an easy enough time programmatically going out and creating these models, creating these components, reading these from the component schema, the resources, the Kubernetes custom resources. They each have schemas. They each have, like I said, a granular listing of different attributes and properties. Great. We can, as a community, as a group of contributors creating Meshery, we can go out and relatively programmatically digest those and reformat them slightly just to fit into Meshery's uniform, model component, model and component. But when we get to a relationship and we want to codify how it is that a cluster role binds, that's, if any of you can figure this out, please say so. But it's there's some human touch that needs to come in here, or like some domain expertise needs to happen where somebody needs to come over and say, it's possible to programmatically discern that these two might relate to one another. It's easier to do it once two resources have established a relationship. So if Meshery is capable of connecting to live running Kubernetes clusters, discovering all of what's running, identifying each of the resources that are running, and assigning them to the appropriate model, so it can visualize your live running clusters. Great, and it could see that you've configured this role to bind to this service account. Great, that's you can in that way programmatically discern the fact that these two things have a relationship. But before you've deployed those, if you're sitting down with a blank slate and there's nothing in your cluster and you're wanting to describe the infrastructure that you need, well, to date, we haven't figured out how else to tell Meshery these three resources can establish a relationship without writing it down. And it's just a simple YAML format. We write down, this one can connect from this one to that one, and it looks like a line. Great. Or it looks like a parent-child relationship. It looks like there's a couple different ways. In order then for Meshery to, in order for this not to be just an endless amount of work, and in order for that codification of that relationship definition to be written in such a way that it's highly reusable and is fairly dynamic, is somewhat non-deterministic. Like, because what if you have 5,000 of these, 2 of these plus 8 different, like the way in which you might be configuring all this and your infrastructure might be running is quite varied. OPA steps in, Rego steps in to help people in this moment, like in the moment where they're trying to understand what the heck is running in their infrastructure, and to like visualize that and model it, show it back to you so you can grok it. But also in the moment in which you're designing your infrastructure, for you to for you to be able to draw this line or not draw this line, to establish a relationship or not. And so, yeah, that's like maybe the most succinctly that I've described that so far, which wasn't very succinct. So we all, and some of you have open PRs. We're all in the process of going around to each of these models and writing down what the relationships should be. Great, great. There's some amount of Rego policy written, some of it generically, so that it's powerful and can handle many different types of relationships that you might want to articulate. And some of it isn't written so generically. Some of it is, but then there's only so many, like it only understands so many different types of potential relationships, and there are more to characterize. Yeah, and so it's kind of funny to say this because those policies and OPA being integrated, that's been there for a long time. But in some respects, we're sort of just at the beginning of heavily going into defining all these relationships. And as we go to do that, it's super scary I think like here, I'll give you, let me show you one example, then I'm going to be quiet, see if we can get some questions going, see if we can. So Meshery, like OPA, has a playground. And Meshery's playground is at playground.meshery.io. To use the playground, you sign in so that you can, one, because there's a live cluster here. So you sign in so that if you're going to mine cryptocurrency, then you can be charged for it, or you can, share that with everybody else. Also, you sign in so that as you put in effort to design your infrastructure or use those models, use those components, establish relationships, that your work gets saved. It gets saved automatically to your account. So half of you, or however many of you, have seen this sort of an interface, or this interface already. Briefly, I would just say that this is a lot like a Google Doc in some respects, or a Google slide. In Google Slides, you might go, draw something on the canvas, on the slide. Meshery is totally fine if you just want to use this as a Microsoft Paint program, or as a whiteboard, and collaborate with others and have others come in live and go back and forth and talk about your infrastructure and argue over it and finger point and call each other names if you want to. Make comments, go through reviews, create your infrastructure designs. All of those models that we were referring to earlier are, all jam-packed inside of here. So we have all kinds of AWS examples, but so you take a component, you go in, you can style it however you want. It's all YAML under the covers, so to speak. Part of what and so this is a custom resource from the EBS, Open EBS project. They have a block device component, which I know nothing about, but apparently if I'm going to use it, I need to provide a file path, I'm assuming. And so Meshery helps you figure that out. Meshery, what we want to do is stop showing people these fields. Make it much, much more intuitive, help people discover and understand that they don't have to start from an empty YAML doc and try to fill it in from memory, but they can just fill it in here. Now, if these two were capable of having a relationship, well, there's various types of relationships, but just as an example, this edge-based relationship, it looks like, nope, these two can't, but these two can. What does that mean? Wow, if Meshery is an orchestrator, so it'll provision this to one or more Kubernetes clusters. So I don't know what the heck that means. And neither does Meshery. Well, Meshery does know. It knows that this doesn't mean anything. It means that you as a human wanted to understand your infrastructure like this, but Kubernetes doesn't need to know that. So it doesn't pass this along. It does pass along your cron job and the fact that you have an ill-described block device. So anyway, the point is, the magic sprinkles, OPA brings in some magic sprinkles, I think, in terms of like how it is that people experience this. Like when I did that a moment ago, in this moment, there's all kinds of JavaScript events firing, and I'm not the best to describe half of what I've described or this, but as I click, and I don't know, I'm not sure how many hundreds of events just fired and things try to figure, but there's a client side evaluation happening, in the same vein that Open Policy Agent performs evaluations. Like, wait, did we just fire off an evaluation using Rego, like using Wasm because you said JavaScript and events and stuff? We want to be, and we have a prototype to be. We're not doing that just yet. We very much desire for that so that people have this very nice, rich and real-time feedback from OPA, from those Rego policies saying, oh yeah, no, there's no relationship here. So don't even bother because it's not going to stick. It's not going to, but yeah, that one, yeah, okay. Now, without going into more particulars at the moment, I'll say that when I clicked and released that relationship from my mouse and I said, establish the relationship, Meshery not only saved your design, just like like a Google Doc, you're typing and it just is saving it, but while it was saving it, it asked OPA to run an evaluation and say, hey, this user is trying to establish this particular type of relationship, like between these two components. What type of component is this? Well, it's a component in Meshery's model. I had said earlier that not all models, not all components represent infrastructure. They can represent lots of different things. In this case, it represents a pen or a pencil of type green and certain thickness and all that stuff. And OPA responded back with, yep, that's okay, and continued to allow the file to be saved. If that wasn't the case, this line should have not established. So there's sort of two levels here of evaluation occurring at the moment. One sort of real-time kind of loose, like, hey, yeah, this is feasible. There's a feasibility analysis happening. This doesn't look like it's feasible. Like we know enough that like at this level in JavaScript, because those relationships were codified, that there isn't a relationship that says from cron job to OpenEBS block device, there isn't one of type edge. So the UI is able to just take things that far and say, let's not even get you on the wrong path. But over here, yeah, we think that this can happen. When we click, we'll go ask OPA in Meshery server, is that okay? Are we right? It responds yes. Yeah. I'll pause. And that kind of brings us up to, yeah. How'd I do, Charlie? How'd I?
Yeah, thank you. Yes, good introduction to both the project and what I think you're trying to do here. And yeah, so I guess it sounds like there are kind of like two ways or two times in where you like really want to do this evaluation of which relationships are either exist or are possible. It's kind of like as you're going along and using this UI, but there's also you said something earlier which I wanted to clarify, was that like you can work out the relationships after the resources have been created, but you didn't have a way of describing the relationships before they were created in the first place. Could you elaborate on that? Like, you're not referring to this UI in that specific example. Is that right?
Yeah, that's right. It's a little bit like this, like shucks. It's a little bit like, it's coming to me. It's loading. If you go to a Kubernetes cluster and you have some resources provisioned, some of them might be using have the same labels, or you might be able to use a selector set or a selector to pair them up and have them interact with one another. This is probably a bad example. Maybe I provisioned these two resources. I labeled them Lee, the user, and maybe when I did, I annotated each of those resources to say that these are managed by Lee, or the user Lee. And Meshery can go over and is continuously synchronizing with all the resources and all that's going on in the cluster. After Lee has done that, it becomes evident that like, oh, these resources can have this ownership relationship, or they can be owned by this entity Lee. Interesting, or but if it was a blank slate for our cluster, it's not all. This is probably a bad example because it's probably technically not true, maybe, but it may not be evident if you go look at the Kubernetes resource deployment. It can have annotations. Okay, yes, that much is obvious from reading the schema or something. It can have labels and annotations. Okay, great. Can those be of type owned by or owner? Maybe, maybe not. I don't know. My knowledge is only, my knowledge stops me in all kinds of ways. But like, let's just say, for purposes of the example, that like it was difficult up front to programmatically discern, to like, ideally as a project, we're not writing out the fact that like, oh, yes, there can be a line between a service and a deployment. Yes, there can. We'll write that down. Like ideally, it would be like, yes, obviously there can be, because we're reading through the schema, not we, but Meshery's code is reading through the schema, and it's evident that one component can relate to the other, and they do it through TCP port such and such. Not all of that is, so since we can't necessarily, so that I'm just trying to recharacterize that bit about sometimes when things are all configured and all set up, it's a little easier to look at it and say, oh yeah, of course those things can have a relationship. But it's sort of like hindsight is 2020, or it's like, yeah, that it's evident because you did it already, but without having, without having, so yeah.
Like perhaps would an example be like, I've got 20 pods and they're in different namespaces, and I can see that half of those pods are in one namespace, but it's easier to see it when they're in the Kubernetes, stored in the Kubernetes API, and you can do kubectl get pods with a particular namespace. Whereas before that point, before they exist in that namespace, they are just some YAML documents on your laptop. Is that like maybe a way to think about it?
Yeah. Like maybe the fact that those resources were namespaced or not namespaced. Let's just say, for purposes of illustration, that like that attribute wasn't described statically, like trying to do static analysis over these components and then discern what all relationships are possible just from what's written into their schema. It isn't the case, or like, or I haven't figured out how that's entirely possible without a human coming over and saying, oh, yes, this is the, yes, if you label that one with a label and label that one with the same label, here's how you can use a selector to tie them together. Generically, if you look at any Kubernetes resource, I think mostly all of them, or generally all of them, are capable of being annotated or being labeled. Now, my limited knowledge tells me that if you can have a Kubernetes service and a Kubernetes deployment relate to one another and establish a network-based relationship by using labels and the same label selector. But that isn't necessarily true if you label a namespace with the same label as daemon set, and then they establish a network-based relationship. It's like that isn't described in the schemas, and so this is where there's a little bit of human work to just write down in a very simple JSON structure. I can bring up some examples that just says, yes, allow a line to go from this component in that model to this component in that model. Yes. And
yeah, I mean, I can imagine some Rego policy which sort of says there is a line or there isn't a line between these two arbitrary resources. You know, and I think in many ways, like Rego is a good way to describe that, because you have more than, you know, you have more than just like, you know, is this field this value in the resource? Is this other field this value in the resource? Like, you want to make comparisons, like are these two you don't want to say like, oh, you don't want to have to define like, oh, each time the owner label. You want to be able to sort of say for an arbitrary set of labels or so on. So yeah, I can imagine using Rego rules to describe these relationships. Yeah, I think that makes sense.
So there's something that I didn't tease out very well, and I'm almost hesitant to, but it's kind of the difference between yeah, using Rego to verify that, like, oh, there is a match, or like, oh, these two should be allowed to form a relationship. Yes, go ahead and allow that line to be drawn. Like that's a helpful thing, and that beyond that though, it's like once you've, and this is a complex slide, but part of what it's trying to say is there's these different phases of evaluation for these relationships to establish. So when I was grabbing my mouse and drawing a line, there's this, so we're sort of in this early evaluatory phase, just this identifying whether or not something is feasible, at least from just looking at just a couple of attributes, not very deeply, and not necessarily authoritatively. We're considering that the Rego rules are the authority, and the one that is supposed to take in a design, that Google Doc or that design that we're looking at with, 200 components, and coming back and saying, oh yeah, here that is possible or that is not. Actually, it would have been possible, except you had 8 cron jobs and a something. So now, no, that's not possible. But like, because so some of the power of Rego that we're looking to do is we want to, try to write the rules relatively generically, and if this makes sense, a little bit non-deterministically, to the extent that perhaps when you go to evaluate whether or not an edge is allowed, it's like the first time the evaluation is run, it's like, yep, the edge between those two is allowed. And now that we have that, oh, wait, let's evaluate again without making any more changes other than just establishing that edge. Oh, because that edge is there, and because there are eight other components, there's another rule that says whenever these two resources have a relationship, it breaks the other one or something. And so you could imagine like getting stuck in a loop of just like running evaluation after evaluation and sort of one relationship negating the next. In a very positive way, though, one relationship facilitating another and sort of building upon another. And it's like, well, if those two are related, then this must also be true, and or allow this kind. So it's both. So yeah, I mean, what we want to have as few rules as possible in some respects, not because we don't want it to be highly intelligent and very specific, but we want for the rules to be, or the more of them that we're writing, the more of it that the more fragile the system. Like the more specific we're getting and the more, minutely defined each of these rules are, is like actually probably it has it's probably an anti-pattern for how these relationships will ultimately be run over time. It's like if you are looking at design and it does have 4,000 nodes on it, it's like you're looking at a cluster. It's got 40 nodes, 50 apps, 50 services, each of which have X number of components, X number of resources, like is a pretty high number. And if you want to look at that on one page to mentally comprehend what you're running and how all these things are interacting, and whether or not it would be a good idea to put in a load balancer or not, that eval needs to take in all that context, or I'm sorry, that evaluation moment, those policies needed to. So as we go to write policies, we can't write one massive one, or we don't desire to. We don't desire to write it super specific, because the more specific it is, the more we've got to write, and the more we've got to write. Like it's not about it being work. It's about it being inelegant, and an inelegant solution is a fragile one. I have to think of better ways to kind of characterize how systems become fragile. The more that you try to optimize, and the more that you try to, like, you don't try to optimize something until the path is well paved, and you're going to stay within those lines, and then you go to optimize it and make it work very well and keep everything in those lines. Over here, we're saying we don't know what those lines are. Like, shoot, and we don't really desire to. Like someone can go in and make up a new component, and maybe that component is to draw a green line with a pencil. And what does that mean? Well, someone just needs to, so yeah, okay. So anyway, so let me ask this. So Uzair and Abid, maybe some of the other folks that work on this a lot, help me tease out, if you would, some of the current challenges that we're having. So one of the challenges is, well, in a big way, we're about to go off and write lots and lots of these relationship definitions, these JSON documents that just say it's okay to have a relationship between these 2 nodes or these 8 nodes. And as we do that, we might say it's okay to have a relationship between these 8 nodes, but if there's a 9th one present, none of them can have a relationship. So we have a way of articulating that, as we have a way of evaluating that in Rego. I wonder if we're doing that right. Sometimes we want to, in general, Charlie, we generally want to be ignorant of and be non-specific when we interact with OPA. We generally desire to, let me go back to we generally desire to take a design, this entire document with whatever it has in it, and just take the whole JSON document, pass it over to OPA, have all of the Rego, it's Rego, right? Not Rego. I'm
Yeah, well, we just work with whatever people say, but we tend to say Rego.
Yeah, if you want. Okay. I get it. I get it. I mean, if you want to sound stupidly, you can say Rego, but the rest of us say Rego. Okay, I get it. Thanks. We want to take the document with whatever it's got in it, sort of ignorantly, and say, can you let us know if this is correct? Or can you let us know if we're missing a couple of relationships that should actually be present? And for OPA, if we have any number of these Rego rules, hopefully most of the time we'll just say, hey, load up all the rules. And here's a doc, run it through the engine, let us know what it's supposed to look like, or let us know what relationships are appropriate or not. Sometimes it is the case that it's like, well, we want to take the whole document, give it to OPA and say, well, actually just run, here's the one rule that we want you to take a look at and evaluate and come back. We ideally, I think, and please other people, point out where you don't think this. I think we generally don't want to be specific. We don't want to say, oh yeah, use this rule to figure that. Because we just generally want to say all of these rules should be well, hopefully compatible with one another, not necessarily conflicting. And we don't have enough of them just yet, and we haven't gotten into a complex enough use cases yet where, oh yeah, we do have a conflict. And so what do we do in that? Like, there's lots that we want to lean on OPA for, conflict resolution, and sort of this non-deterministic, like we don't want to say, we don't necessarily, I don't think, want to say, oh yeah, of the 10 Rego rules to evaluate, do so in this order. First of all, I don't think OPA would much care for that, or maybe not allow you to do that. And second of all, we don't desire to. Like, it's
Yeah, I mean, I see what you want. Like, I think it's fair that you wouldn't want to need to introduce dependencies on these different sort of snippets of logic that tie arbitrary resources together. I think that makes sense. Like, I think your previous diagram of like the different evaluation stages is quite yeah, it looks similar to other sort of systems, I suppose, that I've worked on with Rego in the past, where, I mean, I think a good example is the linter that we've been working on recently, where we evaluate policies on Rego code, and we have this concept of an aggregate rule. So like, sometimes that a linting rule needs to fire, but sometimes you need to wait until an additional evaluation step has been completed. And so in order to describe that, we have this concept of like an aggregating rule. So the violation will only be shown to the user if on that sort of second pass, if you like, of policy evaluation, the policy finds violations at that stage. And that's where I guess you could do things like, you're allowed, I don't know, maybe you could link a GCP service account, but only up to 10 for a project, or something that's kind of representing like a cloud provider limit, or some kind of numeric based limit was an example you gave, but like there may be many others. So yeah, like I think that's maybe how I would think about it. I would think about having two types of policy, one which takes for two arbitrary resources, describes the feasible edges between them, and another one which sort of perhaps validates the output of the feasible edges. So it might be that some feasible edges are labeled like incomplete, or requires aggregate verification or something, and you could have a sort of secondary policy that determines the final output for those rules, those edges.
Yeah, you actually described what I was a little bit hesitant to describe, was like the difference between a Rego an evaluation of to determine to identify a match, like yes, it's possible that these can have a relationship, and maybe they should or maybe they shouldn't, but it would be a different policy that would say, and maybe it's not even, I think it's kind of backwards here. It's like, take a look at all these different aspects of the infrastructure and the way that these things are trying to relate, evaluate, run it through an evaluation. If there is a match, then maybe you want to deny that. Maybe you want to just log the fact that there could have been. Maybe you want for one to mutate the configuration of the other, or like there are these sort of
kind of action items. Yeah. Like it might be that a feasible, you might be that your Rego policy that returns these feasible rules could come with the description of the expected action or what the available actions are. So like some feasible edges might automatically add themselves to the diagram, to the state. Others may be that you prompt the user, do they want to add it? Or others, may have other actions that you want to do, but it could be that the results of that first policy pass, a feasible edge, would just be some data, right? Like, yes, there is a feasible edge between these two resources, and here is some data from the policy evaluation, like a feasible edge of this type. You would want to ask, you would want manual confirmation that this edge was desired, or it might just be that this is a kind of informational connection and it should be added anyway, provided it's in line with the user's preferences or whatever.
Yeah, maybe it costs way too much to actually provision what they're asking for. And so that there could be another type of action. I get the sense that it might be really helpful to Charlie, maybe, if we were to highlight a couple of the policies. Uzair, or do you want to pull up one or two and maybe give Charlie a sense of the size and scope of them today?
Can I ask a quick question while doing that?
Yeah, please.
Yes.
Yeah. I guess this is just maybe a question of scope. So like in Meshery's goal here, I guess there is sort of like relationships and things that maybe are in the schema and like maybe are representing a broken state, such that when you deploy it to the cluster, the cluster would like break and it'd be like, oh, I'm looking for this resource that is required and you didn't provide it, so now I'm broken. But then there's other relationships, I think Lee, you were hinting at about like, let's say you have an operator and it's looking for a resource with a particular label and it's going to do something based on that label. Some of those relationships are a little like looser and maybe require a little more understanding of like intention. Like, okay, I deployed an operator that's going to create a load balancer. It's expecting a certain resource with a certain label. I didn't provide it. That's not going to lead to a broken cluster or an error. It's just sort of not going to do what I intended it to do. So is the goal for Meshery to catch things like that, like, or even model that as a relationship, that's sort of like a looser relationship with like labels and annotations, or is that not meant to be represented within like the visualization in Meshery?
From my part, it is the short answer, is like those examples that you gave, it is the intention for it to do that. It is the intention for people to potentially have a couple of aha moments when they point Meshery at a cluster they've been running for a year. Oh, whoops. Oh yeah, we didn't realize that that port is open, or
It's not being gathered in this way we expected or whatever.
Yeah, or there was so much configure drift between what we had intended to be running and what we are on, or no wonder that application isn't getting the right secret. It's assigned the wrong, like, yeah, any number of those things. I'll say this quickly, that it is the intention for Meshery has some amount of orchestration within it today. Part of the reason that Meshery isn't at a 1.0 is because is our intention to insert a more robust and generic workflow engine that could facilitate a lot of different use cases, some of the ones that you're describing, Chris. Uzair, you were going to show a couple of policies.
So I will be quickly going over to the edge binding relationships. It is the same one that the visual representation of what Lee was showing, which involves cluster role or role binding and service accounts. So on this right hand of the screen, we have like a relationship definition for the so this relationship definition is for my voice is audible, right?
Sort of. Can you start over if you don't mind? It kind of cut in and out.
So I'll be using the example of edge binding relationship and the visualization for which you saw already. The Lee was sharing cluster role binding, and service account. So it involves these kind of components completely related to RBAC, Kubernetes RBAC centric resources. So in this definition, we have defined that we allow relationship from resources which have kind as cluster role and or role. So these are the available relationships or available resources from which a valid edge permission relationships can be created. And these relationships maps to service accounts. So meaning that you can have an edge to a service account. And this intermediary component that we have, like this cluster binding, is captured a bit in a different way. For example, I have this from as cluster role, and I've defined that, okay, this is my intermediary component called cluster role binding for resource cluster role, and role binding is an intermediary component for resource role. And the way relationships work is like I have defined it some kind of like match and path strategies, meaning only allowed. So Rego will only allow the relationship between cluster role binding and service account only if the name, for example, like if the name of the cluster role maps with the role reference inside cluster role binding, and the service account reference for the role binding matches with the cluster role binding name, meaning that we have this kind of form field. So this is the name of the service account, and inside cluster role binding we have like, okay, what should be the subject? So it has that service account, kind is service account, and okay, which service account to use? I have defined that, okay, this is the service account that you want to use. And similarly in the cluster role, I have like rules and cluster role references. So if you see, the service account currently has the name of like only service account, and inside the cluster role binding, the name is incorrect. So it has some additional references. And as soon as I like delete the names, you will see that at this moment of time, the save request got persisted, and at the same moment of time, we invoke the policy evaluation using server-side policy evaluation, which resulted in like okay, this policy is allowed because all of the criteria that we have defined inside this relationship definition matches. So okay, this edge kind of relationship between these components is valid, and here is the corresponding policy for it. So basically, we refer to this every policy that we write needs to take into account only two things: the actual definition and the input. Input in this case is the design file or the YAML file that we are working with. So these are the only two things that the policy should depend on. So in this, we are just extracting like, okay, what are the selectors for this kind of relationship? So okay, from give me all of the components from which the relationships are allowed. So for example, like from selectors to selectors, we are first pre-processing the relationship so that we have the correct data, and based on the design file. So in this design file, we have like 3 components. So we are segregating different components. Okay, like which are the components from which this relationship can be created. In this case, cluster role. So this will contain only those components like cluster roles and roles. This too will contain all the service account inside a relationship definition. And then the evaluation begins of like, okay, does the references, so these are the references.
these path references. So does this cluster binding has correct kind, and whatever service account this cluster binding is referencing, is it correct? Does it matches with the does it matches with the available service account or not? So here the evaluation takes place in this evaluate rule, and this evaluate rule depends upon the design processing that we did earlier here from and to, and the binding components, and it depends on this the references. This we call it as like patch ref, mutated ref, and mutator ref. I'm not sure like if whatever I tell was all clear or not. So if you have questions, feel free to ask.
Yeah, no, I mean I've seen like a similar. I worked on a similar system one time, a long time ago, to do a similar thing where we were interested in creating, these kind of edge definitions between different resources, and we did it in quite a similar way. And the way that you have defined it there, where it's like, this field and these kinds can be linked to destination, from to sort of edge terminology to another resource of this kind if this field is set in this way. And I think that does work quite well. I suppose like when I worked on that system in the past, we were I imagine, based on what I've seen today, like working in a much smaller domain where we are only interested in a particular set of kind of core resources. But if you're interested in reducing the number of policies you have and defining it in a very generic way, which sounds like you are, you might find that, in that JSON example JSON file you showed on the right-hand side, like you're explicitly naming various types of Kubernetes resource. And it might be that you want to have a sort of feasible edge definition, which is, instead of explicitly including certain types, you might want to actually just exclude certain types, or you might want to make it apply to all types as long as these fields are set. And like that kind of thing is easier to express in Rego than JSON. But I guess it's, it's not a silver bullet. You still need to have some knowledge of like where the fields are in different resources, and the kinds of resources that you're dealing with. So, but I would like to think that you could create something more generic with Rego. But no, thanks for sharing the policy.
One of the reasons for like having the JSON file itself is because if you see, we have this only one policy for only this edge binding.rego policy. It performs the evaluation for this thing like edge firewall, edge mount, or edge network relationship. So this involves like different components. So this involves different components. This edge firewall relates to the pod-to-pod communication, and it has like a bit different references of like, okay, which references or which path references needs to be matched and everything. So this particular policy, like as a general practice, what we want is like every policy needs, for example, like there should be a unique combination of kind and type. So in this case, the kind is edge, type is binding. So for every unique combination of kind and type, we want a single policy, because if we go by like for every relationship definition, if we are creating a new policy, then it is like not scalable. And again, we are like into the same thing of like hard coding things. So yeah, this is the like overall flow that we want. And so this was all the case up till like you have created a relationship and server evaluated and gave you the response. We also need an enhancement in this area wherein when I hover over this component, I see like what are the available relationships. So this as Lee said is like completely client side, but again the client side also references this relationship.json file. So in order to, I think in order to perform in Rego, what we want is take all the relationship and go to each and every component and try to extract like, okay, what are the available relationship out of all the available relationship for this particular component. So we are in need of like a policy that does this kind of evaluation, just like pre-process evaluation, like first evaluation.
Yeah, okay. So you want sort of something that's sort of like a kind of wild card on one side as well. Yeah. Yeah, no, I mean, I think you could do that. You could do that too, like if you had a policy that takes two resources, you could also evaluate that sort of the logic of that policy that's matching one of those two resources. It's just a case of how you would structure it, but yeah, I think you could do that too. Yeah, like as we've mentioned in the comments, we've run out of time, but yeah, like it might be good to continue the discussion on OPA Slack, or if you would like to create a channel in your own Slack, and Anders and I could join that. That might be good. Very happy to review example policies that you're working on, or kind of architectures for how you might kind of query your policies with the data that you have from both the front end and or in the server component. Like, there are quite good ways to do that. You might want to look into the OpaGo SDK if you are not using that already. My guess is you're maybe using the Rego package, but yeah, have a look into that, and we can maybe create a space on Slack to chat more.
Charlie, that was one of the politest ways that I've heard someone say, "Hey, I've got another meeting. Can we? This is very helpful, Charlie. We've given it a lot of thought, and I'm embarrassed to say that this is the first time we're speaking to someone from OPA about it directly. It's kind of ridiculous now that we say it like this. It's like, it's a little bit retarded that we didn't get advice and counsel up front. So very helpful.
Good. You're not the first, so don't feel bad. Like, we quite often have people come along who are quite deep into their OPA journey before we speak to them. So yeah, no, thanks for reaching out, and yeah, happy to, like I say, to try and keep the discussion going and help you out with integrating OPA as you need. Yeah.
Well, very good, very good. Yash, so as we go to wrap up the meeting, do we have tomorrow? Do we have a Meshery CI call, a build and release meeting? Is that this week? I wonder.
I need to confirm.
Arbiter, who's there? Anybody else know? Anybody's got the calendar handy?
Yes, it is next. It is tomorrow.
Okay, so tomorrow we've got the weekly newcomers call. So for those of you that are introduce yourselves today, be sure to join the weekly newcomers call as many times as you want to. The point of the call is to have you walk away with a call with an issue in hand. If that's what you're here to do, is contribute in that way. If you're here to contribute by using the projects, then the goal of the call is to have you up and running with the tool, or any of the tools that we have. So we've also got the second build and release call.
Thank you, Lee, for sharing that info, and also do make sure that the timing for the CI call is changed. So you do make sure that you check out the calendar for the layer5.io or we will share that in the Slack and the chat also. We will wait for 5 more seconds if there is any urgent item or any high level issue that you want to discuss. Otherwise, we will wrap up today's call. Okay, so thank you everyone for joining us today. Today's was a productive meeting, and we have learned so much about the relationship, and I hope you also learned about the relationship. If you have any questions, you can directly ask in the Slack channel or open discuss forum, or you can watch the live stream if you have missed any part of the today's meeting. So thank you everyone. We have missed a couple of items today. We will make sure to discuss them same time next week. So thank you everyone for joining. Bye.
Yeah. Thanks all.
Okay, bye-bye.
Bye, guys.
Take a moment.